Hello all. In the last class, we have discussed one-dimensional box and we have found energy eigenstate, energy, and we have extended our discussion to symmetrical box also. Now we have to check some properties of the wave functions in 1D box. Okay. Properties of wave functions. Okay. The first one is it is real. Okay, I am considering the wave functions from this 0 to L. Okay, that is psi n of x equal to root 2 by L sine n pi x by L. Okay, whatever be the length of symmetrical or asymmetric, the box will be the wave function will be symmetric or real. Now they are orthogonal, orthonormal, better to stay. That is psi n star psi m dx is equal to delta n. That is, it is equal to 1 for n equal to m and 0 for m not equal to m. Okay, this is a case. So we have to check this orthonormality condition. For that, I would like to give some valuable integration results for you. Let me give you the integration results. These are very important integration results. I request you to by heart some results. That is sine mx sine nx dx equal to, this is upon integration, sine m minus n x by 2 into m minus n minus sine m plus n into x divided by 2 into m plus n. Sine, then sine m minus n minus sine m plus n, that form. And if you have cos mx cos nx dx, something like this, then here you have sine m minus n x divided by 2 into m minus n. Let me turn off this cam. Now we have a plus. If you have cos, you have a plus. Then sine m plus n divided by 2 into m plus n x. Okay. Now the last and one of the important identity, which is sine and cos intermixing. Sine mx cos nx dx. Now it is minus of cos m minus n x divided by 2 into m minus n plus cos m plus n x divided by 2 into m plus n. Okay, so these are the results. So how to remember this? Sine comes, then sine minus sine. Cos comes, sine plus sine, that form. Sine and cos come, minus of cos plus cos. In all term, first one is m minus n by 2 into m minus n. The second term will be m plus n by 2 into m plus n. So there is a symmetry. You can easily remember this expression. Okay. So let me check the orthogonality condition by applying this equation. Okay. Orthogonal in 1D box. Orthogonal means sine, okay, psi m star psi n dx equal to 0. We have already seen that different states are orthogonal. In 1D box, different states are orthogonal. They are orthogonal to each other. Okay. So what is our state? Let me write it. Our states are root 2 by L sine m pi x by L, because psi m star. Once you take the star, same, because it is a real. Okay. Root 2 by L sine n pi x by L dx from the limit 0 to L. These are two different wave function. We are recorded to get 0. Let me check it. This is equal to 2 by L sine. Then what is equation? Sine comes sine minus sine. So sine m minus n pi x by L divided by 2 into m minus n. Okay. So 2 into m minus n pi x by L minus sine m plus n sine m plus n, that is m plus n pi x by L divided by 2 into m plus n. Okay. Pi. There is no pi x by L, pi by L. Now our limit is from 0 to L. So if you see that, if you substitute the limit x is equal to L, this L and L get cancelled. You have pi here. Sine something into pi. This m and n are integers, right? Therefore, m minus n equal to an integer. Also, m plus n is also an integer. Therefore, m minus m into pi, sine n minus n into pi will be 0, and the sine n plus n into pi will be 0, because they are integers. And also, if you put the lower limit, that is 0, sine 0 is 0. That means you get 0. What does it mean? The different states are orthogonal in 1D box. Okay. Their dot product will be 0. Okay. So orthogonality can be written in this form: psi m star psi n dx. Also, this is equal to psi m psi n. This is equal to 0. This notation and these symbols we will explore it later. For instance, let us write down. Okay. So keep this in mind. They are orthogonal states. Okay. Now, next concept, the time evolution of a state. Time evolution of a state. Okay. What do you mean by time evolution? Time evolution means you have a system here, 1D box, and you have a wave function which is at a psi of x equal psi of t equal to 0. You have the system property at a time t equal to 0. That is, at a t equal to 0, your wave function psi n x 0. That is simply denoted by psi naught. As the time goes on, the system will change. And we want to find the system state when the time is equal to t. That is psi n xt. How do we get this? We can get the time evolution of a system by applying Schrodinger equation, Schrodinger time dependent equation. Okay, I h cross dou by dou t psi equal to e psi. I'm sorry, e psi. So I can write dou psi by psi equal to minus I e by h cross into dou t. So upon integration, I got log psi equal to minus I e by h cross into t plus some constant. How constant can be eliminated? At t equal to 0, your psi equal to psi 0. Substitute this condition, you get ln psi 0 equal to time equal to 0 equal to c. That is c equal to ln psi naught. So our equation ln psi equal to minus psi e t by h cross plus ln psi. So this is simply ln psi by psi naught equal to minus psi e t by h cross. Okay, so I could write psi equal to psi naught into e raised to minus psi e t by h cross. Okay, so this is the state of the system at some time t. In general, I could write the time evolution of the system psi n xt is simply psi of x naught into e raised to minus I e n t by h cross. So you have to by heart this expression. No need to by heart. This is simply a logical thing. That is, if you have a system at a psi of x equal to 0, when you operate with this guy, this is called a time evolution operator. E raised to minus I e n t by h cross. This guy is called a time evolution operator. It will take the system into some time t. അതായത് നിങ്ങളുടെ സിസ്റ്റത്തിന് ഇനിഷ്യലി ഉള്ള സ്റ്റേറ്റ് ഉണ്ടെങ്കിൽ ടൈം എവല്യൂഷൻ ഓപ്പറേറ്റർ കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്ത് കഴിഞ്ഞാൽ കുറെ സമയത്തിന് ശേഷമുള്ള സിസ്റ്റം സ്റ്റേറ്റ് നിങ്ങൾക്ക് കിട്ടും. ഓക്കെ, ദാറ്റ് ഈസ് ഓൾ അബൌട്ട് ദിസ്. That is, your wave function is multiplied with some phase. That's it. നമുക്ക് നോക്കാം നമ്മുടെ വൺ ഡയമെൻഷണൽ ബോക്സിൽ how we can apply this one. Example. I am considering the wave function psi 1 of t equal to psi 1 of 0 okay, let it be here. Ground state of 1D box. Okay, ഇതിലേക്ക് ഞാൻ apply ചെയ്യാം. We know that psi n of x naught equal to root 2 by L sin n pi x by L. So ground state means n equal to 0, n equal to 1. Then your psi 1 of xt will be root 2 by L sin pi x by L into e raised to minus I en, that is e1 t by h cross. Okay, so sometimes you have to this formula is very useful, e raised to I theta, which is, you know, sin theta plus I cos theta. So this is very useful sometime, so keep track of this. Okay, now let us see some example. Question 1. Psi n of x is equal to, or psi 1 of x equal to root 2 by L sin pi x by L. നമ്മളത് കണ്ടു, ഏത് ബോക്സ് ആണ്? 0 to L ലെങ്ത് ഉള്ള ബോക്സ് ആണ് അല്ലേ? Find psi of xt at t equal to 2ml square divided by pi h cross. Okay, so first of all you have to write down your formula. Psi n of xt equal to psi n of x naught into e raised to minus I e n t by h cross. Now you have psi 1 of xt equal to psi 1 of x naught equal to into e raised to minus I e1 t by h cross. Do it separately. e1 t t by h cross. What is E1? N square, that is 1, or En is equal to n square pi square h cross square by 2m length square. So this is pi square h cross square by 2m L square into your t is given by 2m L square by pi h cross divided by h cross. So this is become 2m L square can be cancelled. You get pi h cross square also cancelled. So this is simply pi. Okay. So you will get this is psi 1 of 0 into e raised to minus I pi. E raised to minus I pi is cos pi minus I sin pi. So this is simply minus 1. Therefore, psi 1 of xt is minus psi 1 of 0. This is our answer. Okay. Now, the second one. Psi equal to 1 by root 2 psi 1 of x plus psi 2 of x. Find psi of xt at t equal to 2 ml square by pi h cross. Okay. So again our formula psi n of xt equal to psi n of x naught into e raised to minus I e n t by h cross. Okay, so you here you have two terms, psi 1 and psi 2. So be careful. 1 by root 2 psi 1 e raised to minus I e 1 t by h cross plus psi 2 e raised to minus I e 2 t by h cross. You have to pick e in such a way that it should belong to the same state. For psi 1 e1, psi 2 e2. Okay, that's it. Now do it independently. What is e1 t by h cross? That is e1 is pi square h cross square by 2m L square into your t is 2m L square by pi h cross into 1 by h cross. So this is simply pi, right? What is e2 t by h cross? E2 means n is equal to 2. So n square is 4. Pi square h cross square by 2m L square into 2m L square by pi h cross into 1 by h cross. So simplify this, you get 4 pi, right? You will get 4 pi. So that if you substitute here 1 by root 2 psi 1 e raised to minus I pi plus psi 2 e raised to minus I 4 pi. That is equal to 1 by root 2 psi 1 into minus 1 plus psi 2 into this e raised to 4 pi is simply 0. I'm sorry. This is simply 1. Okay. So what do you get? The final answer is psi of xt equal to 1 by root 2 into minus psi 1 plus psi 2. That's it. This is our final answer. If you are lucky enough, you may get one question from this session. Okay, let me give you more examples. That way you will be very familiar with the concept. Now see the question. Psi equal to 1 by root 2 psi 1 plus psi 2 for 0 less than or equal to x less than or equal to L. That is one-dimensional box of length L. Find psi of xt. Find psi of xt at t equal to 2m L square divided by pi h cross. Okay. So psi n of xt equal to psi n of x0 into e raised to minus I ENT by h cross. This is our equation. Now substitute psi of xt equal to our psi n of x naught is this 1 by root 2 psi 1 plus psi 2 into e raised to minus I. Okay, let me EN t by h cross. This is nothing but 1 by root 2 psi 1 e raised to minus I E1 t by h cross plus psi 2 e raised to minus I E2 t by h cross. I told you you have to substitute separately. E1 t by h cross equal to your E1 is pi square h cross square by 2m L square because your box having length L. Your time is 2m L square by pi h cross. Here it is 2, right? Into 1 by h cross. This is equal to simply this everything will cancel. You will get pi. And your E2 t by h cross will be pi square. E2 is n equal to 2. Therefore, 4 pi square h cross square by 2m L square into 2m L square by pi h cross into 1 by h cross. This is 4 pi. Substituting this guy back here, this implies psi of xt equal to 1 by root 2 psi 1 e raised to minus I pi plus 2 psi 2 e raised to minus I 4 pi. So what do you get? 1 by root 2. This is simply minus 1. Therefore, psi 1 into minus 1 plus 2 psi 2 into 1. So our final answer is this. Psi of xt equal to 1 by root 2 minus psi 1 plus 2 psi 2. So this is our final answer. Okay. Now, next type of question. Psi equal to root 2 by L e raised to 3i pi x by L minus e raised to minus 3i pi x by L. Okay. For 0 less than or equal to x less than or equal to L. On dimensional box. Find psi of xt at t equal to ml square by 2 pi h cross. So this is our wave function. If you see e raised to ikx or our general wave function is root 2 by L into e raised to n pi x by L plus or minus something like that. Comparing with this wave function, you are identifying your n. The state is 3, right? Your state is 3 and your k, that is 3 n pi by L, that is 3 pi by L here. Okay. So what we need, we just need this state only. Okay, and now we can find psi of xt. Psi of xt is simply psi of x naught into e raised to minus I E n t by h cross. Psi of x naught is root 2 by L e raised to 3i pi x by L minus e raised to minus 3i pi x by L. Okay. And your state equal to n equal to 3. Therefore, e raised to minus I E3 t by h cross. because both states are n equal to 3 only here. So you have to just substitute the value and simplify. So first term, if I take, let me write one more term here, e raised to 3i pi x by L into e raised to minus I e3t by h cross minus e raised to minus 3i pi x by L into e raised to minus I e3t by h cross. So if you simplify this first term, you will get e raised to I 3 pi x okay, let me take it. E raised to this term. This is a constant term. This term is e raised to minus I e3. N equal to 3 means 3 square, that is 9, because our en equal to n square pi square h cross square by 2ml square. Okay, so 9 pi square h cross square by 2ml square into t. What is t? For this question, t is ml square by 2 pi h cross divided by 1 by h cross. So this is nothing but e raised to minus I ml square cancel, I 9 pi by 4. Okay, this is nothing but cos 9 pi by 4 minus sin 9 by 4, or let me write it in this way, e raised to I minus I into 2 pi plus pi by 4. So e raised to minus I 2 pi into e raised to minus I pi by 4. This is simply e raised to 2 pi is 1, e raised to minus I pi by 4 is cos pi by 4 minus sin pi by 4. This is 1 by root 2 into 1 minus I. Similarly, if you take this term, e raised to minus 9i pi by 4, okay, the same time is here, so we can substitute it only. So our answer will be psi of xt, substitute here. This is 1 by root 2, I'm sorry, root 2 by L e raised to 3i pi x by L into 1 minus I by root 2 minus e raised to minus I 3 pi x by L into 1 minus I by root 2. So you can take that term outside, 1 minus I by root 2. Everything else is nothing but psi of x naught. So this is our final answer. Okay, this is all about the time evolution of the system. Time evolution. Sometimes they are asking question to find out orthogonality of the states. That is another application of the time evolution. The next session, many times they are asking questions in CSIR. 5 or 6 times they are asking this question repeatedly. So we can move to the next question, orthogonality. Orthogonality. Okay. What is orthogonality in our old systems? Suppose I am taking Cartesian. Let me give you some idea about this. You know that in Cartesian we have 3 coordinates axes, x, y, and z, and they are characterized by their position unit vectors I, j, and k. And you know that I dot I equal to j dot j equal to k dot k. If you take, you get 1. If you take the cross terms I dot j, I dot k, or j dot k, you get 0, which means I, j, k are mutually perpendicular. That is, they are orthogonal. Which means Orthogonality means there is no component of j along I. There is no component of j along I. They are independent. Okay. They are independent. There is no component of j along I or I along k and all. For the case of two vectors, say arbitrary vectors, I am taking, let it be alpha 1 x cap plus alpha 2 y cap plus alpha 3 z cap, and b equal to beta 1 x cap plus beta 2 y cap plus beta 3 z cap. Okay. What is a dot product means? Dot product means the component of A along B or B along A. How much geometrically this means? This is our A, this is B, and we are defining A dot B equal to AB cos theta, right? Which means this is B, then of course this is theta, this is B cos theta. This is B cos theta. A dot B means A B cos theta. That is product of A along with the component of B along A. So dot product will give you how much a vector having component along the other vector. Dot product 0 means two vectors are mutually perpendicular. That is, there is no component of B along A. Okay, that is a physical meaning. Now see, dot product of A dot B, if I take, I get alpha 1 beta 1 plus alpha 2 beta 2 plus alpha 3 beta 3. If A and B are orthogonal, if they are orthogonal, I could say A dot B should be 0, or alpha 1 beta 1 plus alpha 2 beta 2 plus alpha 3 beta 3 equal to 0. That is, sum of products of coefficient of basis vectors. What is the basis here? Our basis is x cap, y cap, z cap are the basis vectors. ആ ബേസിസിന്റെ കോയിഫിഷ്യന്റ് എന്താണോ വരുന്നത് അവരുടെ പ്രോഡക്റ്റുകൾ നമ്മൾ എടുക്കുമ്പോൾ നമുക്ക് എന്ത് കിട്ടും? 0. Sum of the corresponding products of the coefficients of the basis vectors will gives you 0. So keep this idea from elementary algebra. Similarly, we will discuss what is orthogonality in quantum mechanics. For instance, if two functions are orthogonal, psi m star psi n dx equal to 0, which means there is no component of psi m along psi n. They are independent. They are mutually independent. Okay. We have already seen wave functions in on-D box are mutually independent. Different states are orthogonal. We have to prove it in the beginning of this session. Now, let's see some questions based on this concept. Psi 1 equal to 1 by root 2 c phi 1 plus phi 2. Phi 1 and phi 2 are basis states. Okay. Psi 2 equal to 1 by root 5 2 phi 1 minus phi 2. Okay. Check orthogonality. Okay, check the orthogonality. What is the direct method? Let me show that first. Psi 1 star psi 2 dx equal to 0. That is 1 by root 2 phi 1 plus phi 2 star into 1 by root 5 2 phi 1 minus phi 2 dx. equal to 1 by root 2, 1 by root 5. Phi 1 star is simply phi 1. Phi 2 star is simply phi 2. 2 phi 1 minus phi 2 dx. But we know that the states are orthogonal. Different states are orthogonal. Therefore, I could get 1 by root 10 integral phi 1 into 2 phi 1 dx plus phi 1 into minus phi 2 dx plus integral phi 2 into 2 phi 1 dx plus integral phi 2 into minus phi 2 dx. Okay. So that will give you 1 by root 10 phi 1 with the phi 1. We know that psi m psi n equal to delta mn. If the states are same, that will give you 1. Otherwise, that will give you 0. Therefore, this integration will give you 2 plus states are different. They are orthogonal 0. Phi 2 with the phi 1 0. Phi 2 with this phi 2 1. Therefore, you get 1 by root 10. This is not equal to 0, which means states are not orthogonal. States are psi 1 and psi 2 are not orthogonal. This is the method. Okay. But this is very difficult. Therefore, we don't follow this method in examination. Let me repeat that question again by a simplified method. Psi 1 is equal to 1 by root 2, phi 1 plus 2 phi 2, psi 2 equal to 1 by root 5, 2 phi 1 minus phi 2. Okay. I already told you if the states are orthogonal, product of the corresponding coefficient of the basis will be 0. That is psi 1 dot psi 2. If you take, that will give you the coefficients of phi 1 with the phi 1 is, of course, 2 by root 2 root 5 plus phi 2 with the phi 2. Because you know phi 1 with the phi 2 does not exist. Therefore, only you are taking phi 2 with the phi 2. That is 2 into 2 by root 5. Okay. Am I correct? No, I'm sorry. Phi 2 with the phi 2. This is simply minus 1 by root 5, right? Let me write it again. Wait. This with this. So 1 by root 2 into 2 by root 5, right? Okay. Plus here 2 into 1 by root 5. So this is simply I missed this root 2. This is common to this, right? So 2 by root 2. Okay. And here I have minus 1 by root 5. That's it. So this is 2 by root 10 minus 1. Question mistake mistake. First one is just let me correct the question. Psi 1 it was actually 1 by root 2 phi 1 plus phi 2. I made it 2. That's wrong. And psi 2 is equal to 1 by root 5 2 phi 1 minus phi 2. Okay. Now it is correct. Now let me check it. Indianam corresponding coefficient phi 1 in the phi 1 phi 2 into the phi 2. Therefore, you get 1 by root 2 into 2 by root 5, phi 1 with the phi 1 I am take, plus 1 by root 2 into minus 1 by root 5 here. This is equal to 2 by root 10 minus 1 by root 10. This is simply 1 by root 10. I am getting the same answer, but in a single step. Right. So I can say that psi 1 dot psi 2 is not equal to 0. Therefore, the wave functions are not orthogonal. Quantum mechanically, we do not represent this. This should be psi 1, psi 2. Dot product are represented like this. Okay. Now move on to next question. Psi 1 equal to a phi 1 plus 1 by root 2 phi 2. Psi 2 equal to 1 by root 2, 1 by root 5, phi 1 plus 2 phi 2. Okay. Find A if psi 1, psi 2 equal to 0. That means psi 1 and psi 2 are orthogonal. Orthogonal ആണെങ്കിൽ A എന്താണെന്ന് കണ്ടുപിടിച്ചു. നമുക്കറിയാം orthogonal ആണെങ്കിൽ product of the corresponding coefficient of the states will be 0. Okay. Therefore, psi 1, psi 2 equal to 0 imply A into 1 by root 5 plus 1 by root 2 into 2 by root 5 equal to 0. Root 5 will goes out and A equal to minus 2 by root 2, that is minus root 2. So systems are orthogonal, then the value of A will be simply minus root 2. So this is the answer. Okay. So now you are ready to check whether two systems are orthogonal or not, right? Now we extend our discussion by including time. Okay. You will be given a system that will be in some state, and you are required to find when the system become orthogonal to other system, the time at which those systems become orthogonal. Let me give a question. So these type of questions are very important. They are asking several times. Okay. So question: the wave function of a particle in 1D potential is given by, the wave function of a particle in 1D potential is given by root 2 psi 1 plus psi 2 for 0 less than or equal to x less than or equal to L. After how much time the state become orthogonal to initial state? As you know, as time progresses, the system will change. At some time, the state become orthogonal to itself. Okay, so that time we are required to find. So my initial system is given by 1 by root 2 psi 1 plus psi 2. My final state, that is the time at which the systems are orthogonal, that is equal to psi initial into e raised to minus I e n t by h cross. Okay. So let me take it psi final or psi of t equal to 1 by root 2 psi 1 e raised to minus I e1 t by h cross plus psi 2 e raised to minus I e2 t by h cross. I assumed that after time t, the systems are orthogonal. Okay. Now I have found just the system state after some time t. Let me assume, let psi 1 psi of t equal to 0. They are orthogonal after some time t. Okay. Then to check the orthogonality, what do you have to do? Product of the coefficient of the basis states is equal to 0. So psi 1 coefficient, that is 1 by root 2 into 1 by root 2 e raised to minus I E1t by h cross plus here you have again 1 by root 2. Here you have 1 by root 2 e raised to minus I E2t by h cross. If they are orthogonal, this is equal to 0. Right? That simply gives you e raised to minus I E1t by h cross plus e raised to minus I E2t by h cross equal to 0. Therefore, e raised to minus I E1t by h cross equal to minus e raised to minus I E2t by h cross. Okay. Let me rearrange it. E raised to minus I. If I take this term here, E1t by h cross divided by e raised to minus I E2t by h cross, that is equal to minus 1. That is e raised to minus I. If I bring up, that become plus, right? So e raised to minus I E1 minus E2. Am I correct? Yes. T by h cross equal to minus 1. E raised to minus 1 is nothing but e raised to minus I pi. I think e raised to plus or minus I pi, both I can use. Is e raised to plus or minus I pi is minus 1, no problem. But in order to equate this, let me take e raised to minus I pi. Therefore, I can equate E1 minus E2 t by h cross equal to pi, right? So your time will be equal to pi h cross divided by E1 minus E2 modulus. Okay. Because sometimes you may get E2 minus E1 because that completely belongs to this. Okay. When you are taking this time right, then everything will be reversed, right? The minus sign will go here and that term will be E2 minus E1 comes here. No problem with that. No problem with that. You can simply adjust it because if you take the minus outside, this become E2 minus E1, you can take plus only. So whether it comes from E1 minus E2 or E2 minus E1 doesn't matter. Okay. Adendo aikotte. Simply you take the modulus. So this is the time. Okay. So the time at which the system states are orthogonal is given by this. So this is the method. Okay. Now let me give a shortcut. Suppose your system, initial system is 1 by root 2 psi n plus psi n plus 1. The states are successive, n and n plus 1. Then the minimum time, we are looking for the minimum time. You see here, e raised to minus 1 is, you can take many values. Minus 1 means e raised to minus I pi, e raised to minus 3 I pi, or e raised to minus 5 I pi. So everything is good. Everything hold good. But why we took e raised to I pi? Because that is a minimum value. Among the argument, I pi is less than 3 pi, which is less than 5 pi. So I am mentioning here the minimum time at which the states become orthogonal is T minimum equal to pi h cross divided by modulus of En plus 1 minus En, or En minus En plus 1 doesn't matter. Okay. So this is the general expression. Because time cannot be negative, so you have to take accordingly, no issue. Okay. So this is the condition you need out to solve the question when they're asking something like this. The same model comes 4 or 5 times in CSIR. If you are lucky enough, this time also they will ask you. Okay. Now this is all about the orthogonality. We will discuss more such problems while we are taking the previous question discussion. Now we will move on to next session, the shifting of box. Let me take it. New concept, shifting of the wall of 1D box suddenly. Okay, suppose you shift the wall suddenly, what happened? Okay, let us introduce the problem first. You have a system which is x is equal to 0 to x is equal to L, for instance, and a particle is in ground state, suppose, and psi 1 is equal to root 2 by L sine pi x by L, and it is having energy E1 is equal to pi square h cross square by 2 ml square. Okay. Suppose you stretch, you shift the box or shift the wall. Shift the wall means, suppose you take it from x is equal to 0 to x is equal to 2L. But width കൂടുകയാണ്, width കൂടുമ്പോൾ ഉറപ്പായിട്ടും നിങ്ങൾ നോക്കുക ലെങ്ത് കൂടിക്കഴിഞ്ഞാൽ എനർജി അവിടെ കുറയും. അപ്പോൾ പാർട്ടിക്കിള് ചിലപ്പോൾ ഗ്രൗണ്ട് സ്റ്റേറ്റിൽ തന്നെ കാണാം, അല്ലെങ്കിൽ എവിടെ ആയിരിക്കാം, ഫസ്റ്റ് എക്സൈറ്റഡ് സ്റ്റേറ്റിലായിരിക്കാം, അല്ലെങ്കിൽ ഹയർ സ്റ്റേറ്റുകളിലേക്കായിരിക്കാം. Now in the new state, it can be in ground state, first excited state, second excited state, and so on. Okay. So the particle may be retained in the ground state, or it can go to the first excited state, or it can go to higher states. We don't know. But if you know the wave function, we can calculate it. I already told you, we cannot exactly predict the position of a particle, but we can tell about the probability. അപ്പോൾ ബോക്സ് ഷിഫ്റ്റ് ചെയ്യുമ്പോൾ പാർട്ടിക്കിൾ ഏത് സ്റ്റേറ്റിലേക്കാണ് മാറിയത് എന്നുള്ള പ്രോബബിലിറ്റി കണ്ടുപിടിക്കാൻ വേണ്ടി നമുക്ക് പറ്റും. ഓക്കെ, സോ അവർ പ്രോബ്ലം ഈസ് ഫൈൻഡിങ് ദി പ്രോബബിലിറ്റി. ഓക്കെ, ബോക്സിനെ ഷിഫ്റ്റ് ചെയ്യുമ്പോൾ ഗ്രൗണ്ട് സ്റ്റേറ്റിലിരുന്ന പാർട്ടിക്കിൾ ഏതെങ്കിലും സ്റ്റേറ്റിലേക്ക് മാറാം. ഏത് സ്റ്റേറ്റിലാണെന്നാണ് നമ്മൾ കണ്ടുപിടിക്കുന്നത്. അതിന്റെ പ്രോബബിലിറ്റിയാണ് നമുക്ക് പ്രോബബിലിറ്റിയെ കണ്ടുപിടിക്കാൻ പറ്റുള്ളൂ. ദാറ്റ് വി ഹാവ് ടു ഫൈൻഡ്. ഓക്കെ, സോ ലെറ്റ് മീ introduce the probability once again. Probability after while shifting. Okay, the first case is the wave function have no change. Wave function have no change. That is, initial wave function is equal to final wave function. Then I can directly write the probability, which is integral psi initial into psi final, psi initial star psi final dx. Okay, this is a probability. If psi having no change, that is ground state to we are getting a final state where that state wave function is similar to the initial case, then you can use this. But sometime our wave function will change. In the new state, after shifting, psi will change. Okay, then we are not getting the probability. We are not getting the probability. We are getting probability amplitude. Probability amplitude, that is psi initial star psi final dx. To get probability, you have to take square of the probability amplitude. You have to take square of the probability amplitude. That is, your probability is simply taking the probability first, probability amplitude first, psi star initial, psi final. This gives you probability amplitude, and you have to square it. That will give you probability. For psi മാറിയിട്ടില്ലെങ്കിൽ just dot product എടുക്കുമ്പോൾ കിട്ടുന്നത് probability ആണ്. Psi മാറിയിട്ടുണ്ടെങ്കിൽ dot product എടുക്കുമ്പോൾ കിട്ടുന്നത് probability amplitude ആണ്. Okay, you will get probability amplitude. Okay, this is a very interesting problem. Let me give you an example first. Wait. Now our system is in initial state psi I, say 0 to length L. Let me take it in a general case, 0 to x1. Now the box is shifted to 0 to x2. This is a general case. The particle is in final state. That can be ground state, first excited state, I don't know. So the probability amplitude is equal to integral psi initial star psi final dx. So total extension is from 0 to x2, but psi 1 is existing only up to psi 1 is existing only up to 0 less than x less than x1. Psi 1 equal to psi 1 for 0 less than x less than x1 and 0 elsewhere. Psi 2 equal to psi 2 for 0 less than x less than x2 and 0 elsewhere. So if you take the limit, the psi 1 existing only up to 0 to x1. Therefore, 0 to x1 psi 1 star psi final dx plus x1 to x2 psi initial star psi final dx. But unfortunately, in this limit, our psi 1 is of course 0. Okay, therefore probability amplitude is simply 0 to x1 psi 1 star psi final dx. That is, while calculating the probability amplitude, you have to restrict the limit of integration in such a way that in that given limit both wave function exist. Okay, you have to choose the integration limit such a way that both the wave function exists. അതായത് രണ്ട് വേവ് ഫംഗ്ഷനും എക്സിസ്റ്റ് ചെയ്യുന്ന ലിമിറ്റ് വേണം നിങ്ങൾ ഇന്റഗ്രേഷന് കൊടുക്കാൻ. അതായത് നിങ്ങൾ ഒരിക്കലും 0 to x2 കൊടുക്കരുത്. കാര്യം 0 to x1 വരെ psi 1 ഉള്ളൂ. പക്ഷെ അത് നോക്കിക്കഴിഞ്ഞാൽ 0 to x1 വരെ psi f ഉണ്ട്. അപ്പോൾ കോമൺ ആയിട്ടുള്ള ലിമിറ്റ് ബോത്ത് ലിമിറ്റ് എക്സിസ്റ്റ് ചെയ്യുന്നുണ്ടെങ്കിൽ അത് മാത്രമേ നിങ്ങൾ എടുക്കാവൂ. ഓക്കെ, ചൂസ് limit of integration where both psi exist. Okay. Now let us solve some problems. Question number 1. Your psi 1 is equal to, okay, let me take the question. The box of length 0 to L, now it is shifted to 0 to 2L. Okay. Find the probability that particle is found in the ground state of new potential. Find probability of finding the particle in the ground state of new potential. The ground state of new potential. Okay. So you have psi I, which is equal to root, here it is root 2 by L sine, I'm taking it is in the ground state, pi x by L. We are required to find the probability of finding it in the ground state of the new. Therefore, our psi final state is, I am assuming, that the ground state il കാണാനുള്ള probability ആണ് ചോദ്യം. അപ്പോൾ ഇതിന്റെ ground state നമ്മൾ എഴുതണം psi final ആയിട്ട്, which is root 2 by length. ഇവിടുത്തെ length എത്രയാണ്? 2 by L. Sorry, 2L. Sine n pi x by length 2L. Since it is the ground state, psi final equal to root 1 by L sine pi x by 2L. Now you get your psi initial and psi final. They are different, you see. Therefore, probability amplitude equal to integral psi initial star psi final. What is the limit? This is extending from 0 to length L, here 0 to 2L. Which one you take? You should take from 0 to L, because in that limit both wave function exist. Therefore, 0 to L root 2 by L sine pi x by L into 1 by root L sine pi x by 2L. At the beginning of this lecture, I will give you a direct result for this integration, which is, if you take it, you get root 2 by L, right? Root 2 by L integral sine pi x by L into sine pi x by 2L. This is your M, this is your N. Sine വന്നു കഴിഞ്ഞാൽ എന്ത് ചെയ്യും? That is equal to root 2 by L sine m minus n by 2 into m minus n, that is pi pi x by L minus pi x by 2L by 2 into m minus n, that is pi by L minus pi by 2L minus sine m plus n, pi x by L plus pi x by 2L divided by 2 into m plus n, that is pi by L plus pi by 2L in the limit 0 to L. 0 to L. Okay. So this is nothing but root 2 by L. Okay. If you put the limit sin L here, what happened? Sin pi, this is sin pi by 2, this is sin pi by 2 will come here, divided by 2 into pi by L minus pi by 2L is pi by 2L minus, here again if you put the limit L, sin pi minus, sorry, sin pi plus pi by 2, that is sin 3 pi by 2 divided by 2 into 3 pi by L. If you put the lower limit, everything becomes 0. Right. So this will cancel. here is a 2, 3 by 2 pi L, right? Now this becomes, these two again cancel. I can take this pi L outside, then I will get L by pi into root 2 by L. This pi L I am taking out. Sine pi by 2 is simply 1, minus sine 3 pi by 2 is minus 1, divided by a 3 is here, right? So this is L will cancel, root 2 by pi into 4 by 3. So this is my probability amplitude, that is 4 root 2 by 3 pi. My probability is simply square of the probability amplitude, that is 16 into root 2 become 2, 9 pi square, that is 32 by 9 pi square. That is our answer. I will show you a direct method. In one step you can write it, but before that let me discuss one more question. Okay, then I will give you a direct method. Okay, so initially the system in the ground state of this well, ground state. Now I am shifting the box such a way that it becomes 4L. Now find the probability. The system found in the ground state of new well. Okay. പുതിയ വെല്ലിന്റെ ഗ്രൗണ്ട് സ്റ്റേറ്റിൽ കാണാനുള്ള സാധ്യത എന്താണ്? അപ്പൊ എന്ത് ചെയ്യണമെന്ന് പറഞ്ഞു, ആദ്യം ഓരോന്നിനെ ഇനിഷ്യൽ സ്റ്റേറ്റ് എന്നും മറ്റേ ഫൈനൽ സ്റ്റേറ്റ് എന്നും എടുത്ത് വേവ് ഫംഗ്ഷൻ എഴുതാം. ദിസ് ഈസ് റൂട്ട് 2 by L. This is unsymmetrical well, therefore sine pi x by L. This is ground state. Psi final, which is root 2 by length. Length is 4L. Sine ground state, therefore pi x by 4L. Length is 4L. Now the probability amplitude is integral psi initial star psi final dx is equal to root 2 by L into root 2 by 4L integral sine pi x by L into sine pi x by 4L. What is the limit? Common limit is 0 to L. Now this becomes 2 by 2L. Upon integration, this becomes sine and sine, therefore sine minus sine 4. That is sine of pi by L minus pi by 4L. That is 3 pi by 4L into x by 2 into 3 pi by 4L minus sine pi by L plus pi by 4L. That is 5 pi by 4L. X divided by 2 into 5 pi by 4L. In the limit from 0 to L. Now you can take, this is 1 by L. You can take 4L by pi. And this 2 you can take out. So 2 here comes, 4L by pi is coming outside. Remaining is 1 by 3 here. And if you put x equal to L, sine 3 pi by L. 3 pi by 4. Minus, if you put the limit here, you have 1 by 5 on the denominator. The remaining is sine 5 pi by 4. Sine 3 pi by 4 is, of course, which is in the second quadrant. You can solve this 2 by pi, 1 by 3 into sine pi minus pi by 4. That is sine pi by 4. Sine pi by 4 is 1 by root. Minus sine pi by 4 is in third quadrant where sine is negative. That is sine pi plus pi by 4. which is minus 1 by root 2. Here also 1 by 5, right? Therefore, you will get root 2 by pi into 1 by 3 plus 1 by 5. What is 1 by 3 plus 1 by 5? That is 8 by 15. This is probability amplitude, 8 root 2 by 15 pi. Now, what is the probability? Square of it. Probability is square of the probability amplitude, that becomes 8 into 8 into 2 divided by 15 into 15 pi square. That is 64 into 2, 128 by 225 pi square. That is the probability amplitude. Okay. So that's it. So I promise you to give a shortcut method. Let me give you. Now I taught you the concept. Now shortcut method. If you remember this method, you can get it one step. Otherwise, you have to solve it. That's it. I am not encouraging to by heart this one. You can simply solve it because you know the integration. Then simply you will get the answer. Don't make any mistake. That's it. Now, what is a shortcut method? Let me introduce the concept one more time. This is your box. This is having length from x is equal to 0 to x is equal to L. The particle is in initial state. Suppose it is in a ground state. Now, when I excited the particle or shifted the box, listen, x equal to 0 to x equal to NL, n times increased. Box shifted n times. Okay. The particle may be in the ground state, first excited state, second excited state, everywhere. There is a probability that particle can be in any state. Suppose an arbitrary state is M. So this is M the state. Okay. When I shift the box, particle can be in any state. So probability amplitude equal to root n by pi sine n minus m pi by n divided by n minus m minus sine n plus m pi by n divided by n plus m, where m not equal to n. That is the different state anengil. Idana probability amplitude in the equation. Root n by pi sine n minus n pi by n minus m minus sine n plus m pi by n plus m. If m equal to n, the states are same, or probability amplitude is simply 1 by root n, where m equal to n. So remember, box shifted to n times, the particle is in mth state. If the particle is in the same state, very simple, 1 by root n. If the particles are in the different state, you have to use the above formula. Okay. Let us apply this to some problems. Question, let me give to. We have already discussed one problem. Let me give that again. Which one? The box of length 0 to L. Now it is shifted to 0 to 2L. What is ground state to ground state transition probability? Or what is the probability that particle found in the ground state? Here, if you see, your n, number of times it is increased to. Your M, ground state. Probability amplitude is very straightforward, which is root n by pi sine n minus m pi by n minus m minus sine n plus m pi by n divided by n plus m. This is equal to root n by pi. That is root n is 2. Root 2 by pi sine n minus m. That is sine 1. That is sine pi by n 2 by n minus m is 1 minus sine n plus m. That is 3 by n 3 pi by 2 by n plus m is 3. Right? So this is simply root 2 by pi into sine pi by 2 is 1 minus sine 3 pi by 2 is minus 1 by 3. So this is root 2 by pi into 4 by 3. So this is 4 root 2 by 3 pi. This is the probability amplitude. If you square it, you will get probability. Okay. So this is simply probability amplitude only. You have to square it to get probability. You see the same answer. Same answer. Okay. The next question. 0 to L, it is shifted to 0 to 4L. Now your M equal to, I'm sorry, it is shifted 4 times, N equal to 4 and M equal to, I am looking for the ground state probability, M equal to 1. Try to write in a single step. Probability amplitude is equal to root N, that is root 4 by pi sine n minus m, that is sine 3 pi by n, n is 4, by n minus m is 3, minus sine n plus m, that is 5 pi by n, which is 4, by m minus n, sorry, m plus n, which is 5. This one step, it is over. It is root 4 by pi. Sine 3 pi by 4 is, I told you, which is 1 by root 2. Sine 5 pi by 4 is minus 1 by root 2 divided by, you have a 3 here, you have a 5 here. If you take it out, your 1 by root 2, you can take it out. Probability amplitude is simply root 2 by pi. This is simply 1 by 3 plus 1 by 5, which is root 2 by pi into 8 by 15. This is probability amplitude. Square it to get the probability. Okay. The last question. Let me give a question to transition to the higher state. Okay. Now, let your box is this, having length 0 to L. Suppose it is stretched to 0 to 2L, and the particle is in, suppose it is in first excited state. Now your M is equal to 2. Your M equal to again 2. M and N are same. Then the probability amplitude will be 1 by root N. That is 1 by root 2. So probability will be 1 by root 2 square. That is 1 by 2. Okay. One more question. Last one. We will wind up after this. The box having length 0 to L, and we are shifting it to 0 to 4L. Suppose what is the probability to find the particle in first excited state? Now it is shifted 4 times. Therefore, your N is equal to 4. It is in the first excited state. That is, your M is equal to 1. I'm sorry, M equal to 2. Now, what is the probability amplitude? Root N by pi, that is root 4 by pi sine N minus N. Sine N minus N is 2, pi by 4 by sine N minus N, that is 2, minus sine n plus n, that is 6 pi by n, that is 4 by n plus n is simply 6. That is 2 by pi into, this is sine pi by 2, right? That is 1 by 2 minus this is sine 3 pi by 2, which is minus 1 by 6. So probability amplitude is simply 2 by pi into 1 by 2 plus 1 by 6 is 8. This. So this is simply 4 by 3 pi. So my probability is 16 by 9 pi square. Okay. Now there is one more topic. Let me finish. That is the shifting of the symmetric box. That is actually the same concept. Okay, let me finish that also. Shifting of symmetric well. Shifting of symmetric wells. Listen. Now you have a system which is having a symmetric length from minus a to a. Okay. That is system having a length minus a less than or equal to x less than or equal to plus a. Now I shift the box and now it become minus b to plus b. Minus b to plus b. It can have a transition to any state. It can have a transition to any possible state. Now, suppose it is having nth state, arbitrary state is nth state. So what is the transition probability from ground state to nth state? Okay. I'm directly giving you the probability ground state to nth state. How do you solve this one? What is the concept? First, you have to write the wave function for this state, that is psi initial, that is equal to root of 2 by length. Length is minus a to plus a is 2a. Root 2 by length. Since it is a symmetric box, the ground state is cos pi x by 2a. In the last class, we have discussed. Psi final equal to root 2 by length. Here length is 2b. Cos pi x by 2b. This is the ground state. Okay. So probability amplitude for ground state to ground state transition will be psi initial star psi final dx. Same idea. What would be the limit of integration? That should be from minus a to plus a, because it would be the common limit, right? So once you do this, the transition probability from, I am requesting you to substitute and solve. Transition probability, or I'm directly, this is probability amplitude, I am writing probability. Directly probability, how to by heart here. This is equal to which probability? Ground state to ground state probability. 16 a b cube divided by pi square b square minus a square whole square cos square pi a by 2b. This is for ground state to ground state probability. Okay. 16 a b cube, b is the edge of the box. Okay. pi square minus into b square minus a square whole square cos square pi a by 2b. Let me give you the general case, general formula. You should not by heart this one. So general formula, your system is in minus a to plus a state. Now it is shifted to minus b to plus b. And you have end state, transition is to end state. So probability directly, probability from ground state to end state, that is equal to 16ab cube divided by pi square into b square minus na square. Keep in mind, if the state is ground, n is simply 1. Otherwise, you have na square into cos square pi na by 2b. The term a become na, that's it, provided your n equal to odd. Can you predict what would be if n equal to even? Of course, it will be 0. Let me give you the explanation. Let me give you the formula first. Probability ground state to end state equal to 0. Your n equal to even. Why that? Because once you are finding, okay, let me give the box again. This is minus a to plus a. This is minus b to plus b. The ground state is cos. Here also ground state is cos. And all odd states are cos. Cos 3 pi something and odd states cos. Even states are sine. Right? Even states are sine. Here our ground state is cos. So once you are finding the probability amplitude, you are taking the limit minus a to plus a, cos something into cos something if n equal to odd, because in the final state, odd states are cos. Therefore, it exists. Because even function, even limit. But probability amplitude from ground state to n even, that become minus a to plus a cos. This is our ground state, which is cos. Here, if it n is even, that will be sine. Even states are sine. You will get sine here. Odd function, even function, and the limit is, the product will be simply odd. Even limit odd function will give you 0. That is why this is 0. Okay. So try to remember the probability equation 16 pi a cube by pi square by b square minus na whole square. Oh, there is a square. I missed that. I'm sorry for that. Whole square I missed. There is a square again. Cos square pi na by 2b. Let me write it clearly. Probability equal to 16a b cube divided by pi square into b square minus na square whole square, cos square pi na by 2. Okay. So this is all about shifting of symmetric well. And I think now we can stop our discussion. Any doubt you can ask.